Today's lesson's over section 3.7c, talking about rational functions still. This is our third and final case for this. So this is when the degree in the numerator is greater than the degree in the denominator. That means that we will have no horizontal asymptote for this. So we won't have to graph a horizontal line. But in its place, we get something called an oblique or a slant asymptote when the degree on the top is greater than the degree on the bottom. So to find this line, we actually use long division, and the quotient that we get is our equation for the oblique or the slant asymptote. Okay. We may also still get holes for this. We just have to keep an eye out for factors that are in the numerator and in the denominator. Okay. So let's go ahead and try the first example here. So here I have x squared minus 6x minus 7 divided by x minus 4. I want to take notice of the degrees here. So top has a degree of 2. The denominator's degree is 1. So because the numerator is greater than the denominator, we won't have a slant or a horizontal asymptote here. So I can just write none. Now vertical asymptote, just done as normal. Set the denominator equal to 0 and solve. That gets me x equals 4. Then from there, I want to find my slant asymptote. So I'll actually take the division of the bottom from the top and see what I get. Now, because your denominator is like a linear factor, you could use synthetic division for this if you'd like. But sometimes it's not, so long division usually will always get you the correct answer here. So subtracting, I actually get x minus 2 as my quotient. Now, I know that I continue simplifying this, but you really don't once you get that linear quotient up there, because the remainder doesn't matter to anything that we're doing. So even though it's negative 15, I don't really care. So I will write my equation, which is y equals x minus 2, and that's the line that we'll use. Now it's nice because it'll be in slope-intercept form for you every time, so it'll be easy for you to graph. You won't have to find any new points there. Okay, I'll need to factor the numerator here. So it gets me x minus 7 equals 0 and x plus 1 equals 0, and I'll solve for both. That gets me 7 and negative 1. So then I have my x-intercepts of 7, 0 and negative 1, 0. Okay. Then from here, we'll do kind of the same thing we've always been doing for the y-intercept. We'll plug in 0 for x and see what values we get. So it looks like I'll get negative 7 divided by negative 4, which is just 7/4. Or you could write 1.75 if you like. Okay. Now I have all my important information, so I'll start graphing. And once I get that ready, I can graph my vertical asymptote at x equals 4. Now because I have a slant asymptote at y equals x minus 2, I'll plot a point, kind of a tiny point at negative 2, and then use the slope of 1 over 1 to get me the next kind of points. And then I can draw my line there. You don't really need a lot of points. If you want to, you can draw them all, but you just need 2 to make that line be where it's supposed to be. Okay, and then I can graph my x-intercepts and my y-intercept. Now, for these kind of graphs with the slant asymptote, our graphs look kind of similar to when we just have, when we just have 1 on each side. Remember that your lines are trying to approach the asymptotes, so they're going to curl a little different because the sides are a little more angled, but they still kind of approach the same kind of way. Okay, moving on to letter B here, same thing happens. The degree on the top is greater than the degree on the bottom, so that means I'm not going to have a horizontal asymptote. Okay. Then I can set the denominator equal to 0. And just so you know, for this video, I probably should have factored the numerators first before I started defining what degrees everything were and finding the vertical asymptote to make sure that there weren't any holes. But usually if you just have one factor in the denominator, it's not going to matter because you're probably not going to have a hole with one factor in the denominator. It's probably just going to be a vertical asymptote. So I get x equals 3 as a vertical asymptote. It looks like I will get x minus 1 as a slant asymptote. So I'll write y equals x minus 1 there, and then I can look for my x-intercepts by setting the numerator equal to 0. But I'll probably need to first factor it. So I'll get x minus 5 times x plus 1. And set that equal to 0. Solve, so I'll get x-intercepts of 5 comma 0 and negative 1 comma 0. Okay. Then from there I'll look for my y-intercept by plugging in 0 for x. Okay. And then it gives me 5/3, it looks like, so I'll have 0 comma 5/3 as my y-intercept. And then I can go ahead and graph. Okay, now we'll first start by graphing my vertical asymptote at x equals 3. And then at negative 1 on the y-axis, I'll draw a little point, then use the slope of 1 over 1 to get a couple more points, and then draw that slanted line for a slant asymptote. I'll graph my x-intercepts at 5 comma 0 and negative 1 comma 0, and then my y-intercept at 0 comma 5/3, which is about 1.67. So then here, once again, I draw my lines so they can kind of approach my asymptotes, and there you go. Have fun.